Good day, guys and girls. This is probably going to be one of the most boring videos that I've ever done because you won't be seeing my face as I usually do. But nonetheless, I wanted to take you through the galvanic cell very quickly, just as a quick reminder. So I've got a question that's already prepared for you, so let me just get to it. I hope you've been preparing very well. So, and I also hope that as I do this question with you, it will just serve as a reminder of the things that you've already covered, whether with your teacher or with any other person that is helping you with chemistry. All right, now let's get to this question. All right, quickly, I've just drawn a question there of a typical galvanic cell. All right, so this galvanic cell, they gave us a zinc and copper cell. Now, in answering this question, I've always found it very easy for us before we start looking at the questions. All right, I want to just quickly show you a way in which I always deal with the galvanic cell. Of course, you're going to use that standard reduction potential table, okay, and obviously that's the table, and it doesn't really matter whether you use the 4A 4B table. I'm going to show you very quickly. So what I'm going to do with you is just show you the things that I always do to kind of prepare before I answer the questions. All right, so first of all, I always say just check what are the electrodes that you are given, okay? And note, so what did they give us? They gave us zinc, okay? And they gave us copper. And now you need to be careful about copper because there are three standard electrodes of copper in your table. So here we are going to look at copper 0, okay? The one without a number, and copper 2+. So you need to go for that one, that is copper 0 and copper 2+. Now let's first of all identify them. Okay, so first of all, we are going to find zinc. Okay, all right, there it is there. I'm just going to highlight it. Okay, can you see it's got a minus 0.76. Okay, you can take out your table as well so that you can identify it. And then I'm going to find copper 2+ and copper 0. Now remember what I said about copper. So can you see this one? It's copper plus and copper 0 on the other side. So that's not the one. It's got only a 1+. Okay, let's go to the next one. That's copper 2+ and copper 0. So this is the one that I'm going to use. Okay, and the potential thereof is positive 0.34. So now that I've identified them, okay, I'm just simply going to write them down on my table. As part of my preparation. So this I'm just doing on the side just before I get started. So I found copper 2+ plus 2 electrons giving me copper. Okay. And then I found zinc 2+, okay, we got that one to be 0.34, okay, and then zinc 2+ plus 2 electrons. I'm copying them exactly as they are on my potential table, and we found this one to be minus 0.76 volts. Now, all you simply do, now that we've identified our potentials, okay, or our electrodes, all I'm simply going to do, now I want you to listen to me carefully. I hope I'm not going to offend anyone. All right, there's a mnemonic that I always use that just makes things quite easy. So I'm not trying to be political in any way, but I promise you it will help you to remember some things. So now what I want you to do, the first thing that I want you to do is to draw a number line, okay? You remember a number line? You always start with the smaller numbers and you go to the greater numbers as you move towards the right. Right, now I want you to identify between these two numbers, which one is the smaller number. Of course, it will be minus 0.76. So it means it comes here, minus 0.76. And this will be 0.34. Okay, now look at this. I've got my numbers in ascending order, okay, increasing that way. And then I know this number here, minus 0.76, is for zinc, and this number here is for copper. Okay, I got it from the copper half reaction. Okay, and then all I just simply do is ask myself a question, right? Which party is in government? Okay, and then all I just simply do is to remind myself it is the ANC. Okay, and by the way, what is the ANC very famous for? Okay, we say the ANC gives away houses. I hope I'm not going to get into trouble for that mnemonic. Okay, so which is the most which is the party in government? We said the ANC, right? And what does the ANC do? It gives away houses, but in this case, our houses are electrons. Oh, by the way, as I said, so in this case, electrons are going that way. Now, what this helps you with is that now you can quickly identify which one is your anode. So it means that zinc will be your anode. Can you see that? And then copper will be your cathode. All right. Now, what you simply do, now please listen to me very carefully, ladies and gents. So what you simply do, the one that is the anode, you'll always take the half reaction of it, okay, and write it the other way around. So it means now the actual reaction that is taking place in this cell that we have there, right? So it means that now I'm going to take the zinc half cell and I'm going to change it the other way around. It's going to now become zinc, okay? So I'm changing it around. Now, what was on the right now goes to the left. So zinc becomes, now note, I'm placing one arrow, okay? Right, so that's becoming zinc 2 plus 2 electrons. So whatever was on the left goes to the right, whatever is on the right goes to the left, and the other way around, dang it. Right, so in this case, I've got zinc going into zinc 2 plus 2 electrons. So the one that is the anode, you take the half reaction and you write it the other way around. And the one that is the cathode, okay, so you write it exactly as it appears. So this is going to be copper 2 plus 2 electrons. I'm writing it exactly as it appears. The only difference now is that instead of 2 arrows, okay, I'm going to write 1 arrow because this is the actual reaction that is taking place in the cathode, okay? So now I now want to find my net cell reaction, okay? So remember, I haven't started answering any questions, right? So in this particular case, what am I going to say, okay? So now you must check that the electrons that are given, now it means that zinc, okay, the solid form of zinc, the metal, is now becoming zinc 2 plus. It's undergoing oxidation, right? It's becoming zinc 2 plus by giving away 2 electrons. Can you see that? Okay, and what's happening? So it means this one is giving away electrons. So therefore we know it is the anode. Remember, we have that another mnemonic. We always say an ox. In common, an ox. All right. And so the anode undergoes oxidation, okay? And then we always have that red cat, okay? So what does that mean? It means reduction occurs at the cathode. I hope that will help you to sort of remember in a way. Right, now, I now need to check, are the electrons that are given equal to the electrons that are received? Okay, so here copper 2 plus receives electrons, okay, gains electrons and simply becomes the solid form of copper. So in this case the electrons are equal, so what do? I just simply cancel them out. Now let's write down the net cell reaction. What do we have? So I write down everything that is on the left hand side of each equation. So what am I left with? I'm left with zinc plus copper 2 plus, okay, which will give us zinc 2 plus. Now remember, I've got everything that's on my left hand side. Now I'm going to the right hand side, 1 arrow once again, zinc 2 plus plus copper. So this is my net cell reaction. Okay, now quickly, I want us to answer some questions, and then we're going to look at past exam questions in just a little while. Now, they say state the energy conversion that takes place. I just wrote this question to be very short, so I didn't write down everything. So the energy conversion that takes place in a galvanic cell, remember, we are converting chemical energy into electrical energy. Okay, so remember what a galvanic cell does is that it converts chemical energy into electrical energy. Okay, right. Now secondly, they ask us which electrode is the anode. Now please be careful, I just wrote down this question in a very generic way, but sometimes they ask you for the name and sometimes they ask you for the symbol. Now if they had asked us for the name of the anode, so if you remember, we said anode, which one is the anode? That's the zinc, isn't it? That's the zinc half cell. So in this case, you would have written there, if they asked for the zinc half cell, okay, that would have been zinc. Or if they asked for the symbol, you just simply write Zn. Okay, right. And then they say to us, write down the oxidation half reaction. Remember, we said which one undergoes oxidation? That's the anode. Okay, so which one is the half reaction? You don't write those ones. Okay, remember, those ones, we just copied them as they are. You write the ones that you've kind of adapted for the particular cell that you are actually constructing, right? So which one is our half cell? It's this one. And please just be careful, ladies and gents, that you write it down with one arrow. So that's going to be Zn. You see, now I'm just doing copying work. Once you've done this, it just makes everything just become so much easier. So that's Zn, giving us Zn2 plus 2 electrons. Please note, it's just with one arrow. All right, so it's telling us this is exactly the reaction that is taking place there. Right, and then the next question says write down the net cell reaction for this cell. Okay, so we are doing some copying work. So all we simply do is write that one down there, right? So that's going to be Zn plus copper 2 plus, giving us, we said Zn2 plus copper. Okay, sorry if it looks messy. Sorry about that. Okay, right, I'm just going to take my the sheet that I'm using just a little bit upwards for the next section of the question. Now they say calculate the initial reading of the voltmeter. So essentially what that is calculate the EMF of the cell, isn't it? The EMF of the cell. Now there's a reason why they say initial, because over time as the cell continues to operate, okay, what happens is that because it is a closed system, then the reaction becomes reversible, and then over time it does reach equilibrium. And if it reaches equilibrium, I mean, all it simply means is that that EMF value eventually becomes zero. So you'll see that the value begins to decrease, and over time it becomes zero. So that's why they'll always specify calculate the initial reading of the EMF. And all we simply do for that, okay, if we remember, I hope you can see that, okay, you know you've got this in your data sheet, right? So that's E cell, that's going to be E cathode minus E anode. So let's write that down. So E cell, okay, is equals to E cathode, that's the standard version, okay, minus E cathode, E anode, okay. Now all we simply do, which one did we say is our anode? Okay, remember from there, so we said our cathode is going to be copper. What's the potential for copper? All right, for the copper half cell, that's 0.34, so that's positive 0.34. okay, remember there's a minus there. What's the potential for our anode. Our anode, we said that's zinc, okay? And what is the potential for our anode? That's minus 0.76. So that's minus 0.76. And look at that. So now you've got 0.34 minus a negative 0.76. And what does that give us? Okay, you can punch that on your calculator. You'll see that you'll get a value of 1.1 volts. Okay, remember our E cell should be in volts. Okay, right. So it means that our E cell, sorry, my handwriting looks a little bit terrible there. Okay, so my E cell is 1.1 volts. I hope that kind of makes sense, ladies and gents. So I'm gonna take this up a little bit because I also want you to see that portion. All right, so let's take it down a bit. Okay, so they say write down the cell notation for the cell. Now a very popular question, because sometimes they may give you the cell notation and actually require you to write down, or rather to construct, or to kind of interpret the cell. Now please, I want you to remember this. When you write down, there's a difference between the net cell reaction, which is this one here, and the cell notation. Okay, right, which is the one that we're going to do just now. Okay, so now how do we write down the cell notation? I want you to please note, you always start with the anode on the left hand side. Which one is our anode? Our anode is zinc. And what happened to zinc? It started as zinc. Okay, so zinc started as the solid form, okay, without any number there. And then this one backslash, okay, it simply means it changed in phase. Okay, so zinc solid, okay, changed phase and became zinc 2+. Okay, can you see that? It started as Zn and it became Zn2+. And then this double slash here shows us, or rather the interpretation of it is the salt bridge. So if they ask you what this stands for, it stands for the salt bridge. This one here stands for the change in phase. So you start with the anode on the left hand side, and then on the right hand side, please have a look at this. What happened on our cathode? It started as copper 2+, and what did it become? It became copper. So this will be copper 2+. Oh, by the way, these are in aqueous form. Okay, so this is in aqueous form. For as long as it has those pluses and minuses there, it's in aqueous form. And what happened? It changed phase and it became a solid. Okay, so it changed phase and became solid. So look at this here, the half reaction. It started as copper 2+, and what did it do? It became copper. All right, so I hope that kind of makes sense to you. All right, and now they ask this final question: what are the standard operating conditions? Now you'll notice when we wrote there, it says E cell and it's got that sort of 0 there at the top. And what this simply means, it's standard. Okay, so it means this is the E standard. Okay, and what are those standard conditions? So there are actually 3 standard conditions, depending on whether one of them is a gas or not. Okay, so the first one is that it must be at a temperature, okay, it must be conducted at 25 degrees Celsius, which is room temperature. Okay, and then the second one, the initial concentration of your electrolytes must be 1 mole per cubic decimeters. Those are the 2 standard operating conditions. Okay, now if one of your electrodes is a gas, okay, we say that the pressure at which you conduct this cell, all right, must always be at 1 atmosphere. So that's 1 atm, or that's 101.3 kilopascals, or you can just round it off to 100 kilopascals. All right, I know that that's a lot of writing there. Okay, so I want you to just know how to construct that cell. Okay, let me just take you through that again. So we said, all right, you started here you identified your electrode, zinc and copper. So you wrote them down as they appeared from your standard potential table. We identified them. Okay, we found them. And then we just simply wrote them, and we constructed that number line, started from the least to the greater number. And then we asked ourselves that question, which party is in government? And we said ANC, right? And what is the ANC famous for? Giving away houses. Okay, our houses are electrons in this case. Ho, ho, ho. All right, so all right, so in this case, then all we simply do, we identify that zinc is the anode and copper is the cathode. And remember, we said the anode, you take the half reaction of it and you write it the other way around. Okay, so I hope that kind of makes sense, ladies and gents. So what I want to do next is, let's just take a past exam question and let's do that one together. Okay, so let me leave that question there so that it's in your shot. Okay, you can see it. Sorry that you know, I don't have my assistant today. My wife always helps me with the videos, so I'm actually doing it all by myself today. Yeah, so there it is there. Those are all the questions and the answers. All right, I hope that you are able to see it. All right, now let's go to the next question. All right, so I took this question from last year's, that 2019. That's the May-June question paper. I hope you can be able to find it. Okay. Okay, I see that we can't really see properly there. Let me just zoom in a little bit. Okay, but please try and find it for yourself there. So what did they give us in the cell? Sorry if you really cannot see that properly. Okay. Right, so they say the electrochemical cell below functions under standard condition. You remember those standard conditions, right? We said that's 25 degrees temperature. That's 1 mole per cubic decimeters concentration, your initial concentration. Okay, and you see one of them is a gas there. Okay, you've got a gas, so it must be at 1 atmosphere. Now, let's first of all do what we did before we start answering all the questions. Okay, I'm just going to do it at the bottom there. All right, I'm going to do that at the bottom there. Now let's first identify which ones are our electrodes. Okay, our electrodes, so we've got chlorine gas there. Okay, and we have chromium there. All right, so I'm going to go to my standard potential table. Okay, let's first identify them. All right, please go to your own standard potential table. Let's take a different color. So I've got chlorine. So let's first find that. Okay, there it is there. Okay. All right. And I'm also looking for chromium. Okay, there it is at the bottom there. Okay. So those are the two in green. Okay. So I'm just going to write them exactly as they appear. Okay, so I've got Cl2 plus 2 electrons, giving me 2Cl minus, and that's positive 1.36. Okay, I also have chromium at the bottom there, Cr3 plus 3 electrons. Okay, giving me okay, giving me Cr, and I'm trying to find the value there. That's minus 0.74. Okay, so remember, what did we do? We said the first thing that we're going to do, so before we start answering questions, right, we said the first thing that we're going to do, we do this for ourselves, right? Right, so we said first of all, you draw that number line. Okay, which one is the smaller number? Of course, it's going to be minus 0.76, isn't it? 74, sorry. Okay, and the bigger number is 1.36. Okay, Right, and then we ask ourselves, okay, so the minus 0.74, that's the chromium, so that's Cr, and then this one is the Cl, okay, or we can say Cl2, okay. So what are we going to do here? We're going to now ask ourselves that famous question: which party is in government? Okay, that's ANC, okay. And what is the ANC famous for? For giving away houses, okay. Right, now if you have a look at this quickly, all right, so what does that tell us? It tells us that chromium in this case, all right, chrome is going through it's an anode, so it's giving away electrons. You can see electrons come from there, they are going to the other side, and chlorine is basically or rather chloride is receiving electrons, okay. So we said the one that is the anode, you write it, okay, you take it and you change it around. So I'm just going to do that. So it's going to be Cr, okay, with one arrow. Please remember that. Now it becomes Cr3 plus 3 electrons. Can you see that? All right, and the one that is the cathode, okay, right, we said we just write it exactly as it is. So this now becomes Cl2 exactly as it is, Cl2 plus 2 electrons. And what does that give us? It gives us 2 Cl minus, okay. Right, now this sets us up for a very interesting one, okay. Remember we said now we must check, are the electrons equal? All right, no, they are not in this case, but how can we get them to be equal? So you'll notice here we're going to apply what we call the lowest common multiple, okay. It means that's the smallest number that is divisible between these two. So what's the smallest number that is divisible by 3, divisible by 2, that does not leave any remainder? Of course, that's 6, right? So how do I make this one 6? So it means I must multiply everything here by 2, so that everything now so that this becomes 6. So I'm going to multiply everything by 2. So 2 times 1, that's 2, okay. 2 times 1, that's 2. So I'm multiplying the coefficients, right? And 2 times 3 is 6. Can you see that? Okay, yeah, sorry if it looks a little bit clumsy. Right, and then how do I get this one to be 6? Multiply by 3, okay. So it means 3 times 1, that's 3. 3 times 2 is 6. And then 3 times 2, once again, is going to be 6 as well, okay. Right, so in this case, what do I have? All right, now I've got both of them being what? Being 6. Can you see that? Okay, so what do we have ultimately? Now we can cancel out the electrons, okay. All right, I hope you can see that clearly there. And now what are we going to do? We're going to write down everything that's on the left hand side, okay. So that's going to be 2Cr, okay, plus 3Cl2. And what do we have? That's 2Cr3 plus, okay, plus 6Cl minus. Can you see that? Okay, so we've identified which one is the anode, which one is the cathode, and so on and so forth. Now let's focus our attention on answering the questions, okay. So let's focus our attention on just trying to get those answers there. So the first question says to us, give a reason why platinum is used as an electrode in half cell A. Now please, ladies and gents, remember platinum, you remember we've got a, by the way, chlorine is a gas there, okay. So gases are not really famous for conducting electrons very easily, isn't it? And here you are dealing with the conversion of chemicals or chemical energy into electrical energy. So what that platinum helps us with is that First of all, platinum does not undergo oxidation very easily. All right, so it's chemically unreactive. Okay, all right, it does not react very easily. So as a result, it will help us with electrical conductivity. Okay, so it will help us with conducting electricity very easily. So they say give a reason why platinum is used. It's for electrical conductivity. Okay, right. And then the next question, they say write down the energy conversion that takes place in the cell. So since it's a galvanic cell, we know that's going to be what? That's going to be electrical energy. So if you don't mind, I'm just going to write there. So that's that's going to be chemical energy to electrical. Okay, that's electrical. All right, so we know we are dealing with chemical energy to electrical energy. Okay, now very interestingly, what do they say to us? Let me just put this on the side here, okay, so that you can see it. They say write down the half reaction that takes place at the cathode. But you see, now you've already done that for yourself. Which one is the cathode? We know that's the chlorine. Okay, so which is the half reaction that took place there? So that's the Cl2 plus the 2 electrons. You remember we adapted this, and it really doesn't matter even if you give the one that was there originally. So that's going to be Cl2, okay, plus 2 electrons, giving us, now please notice, with one arrow, please, ladies and gents, okay, with one arrow. Let me put that paper there. And what does that give us? We said it gives us 2 Cl minus. Okay, right, I hope that you remember that clearly. Okay, and then so we've answered 8.2.2. okay, and then they say give the cell notation for the cell. Oh, beautiful stuff. Now that you know how to write down the cell notation, okay, so that's 8.2.3. okay, we said we always start with the anode, isn't it? Okay, now please, I want you to remember this. Which one is our anode? We said that's the chrome. Okay, so in this case we've got Cr. Okay, that was before we multiplied by 2 there. Okay, so you don't need to show that in your cell notation. There's a difference. This is a net cell reaction, and what I'm writing down here is the cell notation. Now, how do we write down that cell notation? We said all I'm simply going to do is Cr changed, and what did it become? It became Cr3 plus. Can you see? So Cr, which is solid, changed in phase and became what? Cr3 plus. Okay, remember this is aqueous. All right, and then we said this shows us the salt bridge. Okay, and then what happens now? And chlorine, which started as Cl2, okay, now changed in phase. By the way, this is gas. Okay, changed in phase, and what did it become? It became Cl minus. Can you see that? So if you note there, I'm not writing the coefficients. So this is Cl2. Sorry, I wrote this in quite a clumsy way. So that's Cl2 that changed in phase, and what did it become? It became Cl minus. Remember that changed in phase there. Okay, I actually didn't show that these are that's a backslash. Okay, right, if you want to, you can actually show that this happens in the presence of platinum, so you can just write with platinum there. Okay, right, so this is how you, oh goodness, that looks horrible, but I hope you can still understand. Okay, right, so that is the next question that we're answering. Okay, now let's get to that next question. Now we're answering the next one. They say calculate the EMF of the cell. You intelligent people, I know you already have figured that out. So that's 8.3, sorry, that's 8.3. So we said what? E cell, okay, standard, is going to be what? E cathode, that's standard, minus E anode. Okay, right. So what are our potential? We said which one is the cathode? That's chlorine. That's 1.36. Okay, minus. Okay, remember there's a minus sign there. Minus, once again, our anode is negative, so that's minus 0.74. Okay, and what does that give us? So that's sorry about that. Okay, so there's our calculator there. So we're saying 1.36 minus a negative 0.74. Okay, and that gives us 2.1 volts. Okay, so that should be the initial EMF of the cell. Okay, so that should be the initial reading of the galvanic cell. So obviously I did say to you that over time, as the cell begins to operate, that value decreases up until the cell reaches a state of dynamic equilibrium where that value will be 0. Okay, right. Now the next question, right? So can you see how many marks you would have actually maximized on just by simply knowing what I showed you there? Right, and then the very last question, they say silver chloride, okay, is an insoluble salt. What does that mean when they say it's insoluble? It means it does not dissolve in solution, or it does not dissolve in water. It does not break down to form ions, right? So they say, what will be the effect of the cell potential when a small amount of silver nitrate, okay, is added right, yeah, is added to half cell A. Choose increase, decrease, or remain the same. All right, I understand this may not necessarily be the easiest question to answer, but I want you to really think about this. We've got a cell notation there, okay? Once you add silver, what silver does is that it will now begin to take away those chloride ions. And it's kind of an application of Le Chatelier's principle, for those of you who know how to apply Le Chatelier's principle. So remember what I said to you is that, remember that reaction can end up being reversible, right? Now, when I add a silver nitrate, those silver ions actually begin to take away the chloride ions, okay? So it takes away the chloride ions. Once it takes away the chloride ions, now, okay, the forward reaction is favored, okay? Remember, when we decrease on the right-hand side, it means I'm favoring now the forward reaction to try and replace, okay? And anything that favors the forward reaction will actually increase our potential value, okay? Our cell potential. So in this case, it means the forward reaction is favored, so it means the cell potential will do what? Will increase. So there'll be a slight increase in that cell potential value. Okay, right, ladies and gents, I hope that question kind of made sense. I'm just going to take that out of the shot so that you can see it there. Okay, remember I sourced that question from last year's May-June question paper. All right, you can go and look at it for yourself. Okay, and that is how we will answer that question. So what I want to do is I want to just take one last question. All right, I hope that will kind of help as you answer questions on the galvanic cell. Okay, I can actually hear someone saying, yeah, sir, you've shown us how to calculate when you are given both potentials, but how do I know how to identify which electrode is given when I've got a question where one of them is unknown? All right, we're getting to that type of question just now. All right, now this, by the way, is the November 2019. So that's last year's November paper. That's for the final exam. Okay, so you can look at that question for yourself. Okay, right, now what do they say to us? They say a standard electrochemical cell is set up using two half cells as shown in the diagram below. So there's the diagram that they gave us there. So there you've got chlorine. It almost looks like the one that we had. Can you see that? Okay, so it's almost like the question that we had previously. Okay, right, so let's see what questions they ask us. Now in this particular question we are now limited. We can't exactly do what we did previously, you know, our kind of ANC gymnastics, because now we don't know which cells we are dealing with, or one of the half cells that we are dealing with. Right, but let's try and answer the question. We'll take it step by step. Okay, so there will be additional information that you are kind of given. All right, okay, so what do they say to us? They say state the energy conversion that takes place in the cell. I'm sure by now you're thinking, oh, we've seen this question too many times, right? So the energy conversion that takes place, this is from chemical to electrical energy. Okay, so I'm just going to say from chemical energy to electrical energy. Okay, this is me being lazy now, né? So that's chemical energy to electrical. Now please remember, in the electrolytic cell, okay, that's where you've got electrical energy being converted to chemical energy. So means that when you're dealing with the galvanic cell, the galvanic cell is a we say it's a spontaneous reaction. Okay, it means it will take place on its own. All right, in a sense. But the galvanic, the electrolytic cell requires an external source of energy, okay, which in that case would be electrical energy. Now, okay, so we're done with number one, and then they say what is the function of component Q? First of all, what is component Q? That's our salt bridge, isn't it? Okay, and what is the function of the salt bridge? Okay, we say that the salt bridge, it neutralizes you know what, I'm setting myself up for some trouble there. So it neutralizes, so to neutralize excess ions. Okay, and then the second thing is that it completes the circuit. Okay, so without that salt bridge, this circuit, it's almost like you've got an open circuit. You remember in electricity, right? Ohm's law. Once you've got a switch that is open, the current cannot flow, isn't it? So that's exactly what the salt bridge does, is that it just simply closes that gap there, so it completes the circuit. Okay, right, the circuit. All right, there we go. So those are the functions of the salt bridge. Right, so now they tell us that X is a metal. All right, a voltmeter connected across the cell initially registers. You remember what we said about that initial part there, right? Okay, so in this particular case, let's see, what are we given? They say in X is a metal, a voltmeter connected across the cell initially registers 1.49 volts. Now, I'm not too happy in a sense about some aspects of this question in the manner in which it was asked, because you know, normally what the examiner should do is kind of give you some kind of a clue, all right, as to which one is the anode and which one is the cathode and so on, right? But in this particular case now, you have to rely on certain previous knowledge. Okay, Right, now if you remember that question, the previous question that we had, né? If you remember the previous question that we had, remember we had chlorine gas coming in there, okay? Right, do you remember that chlorine actually acted in that case? It was undergoing reduction, okay? Do you remember that? So it was undergoing reduction. So in this case, if you remember, we took Cl2, where was it? Okay, we took Cl2, we had chromium undergoing oxidation, and we took Cl2, which they are pumping in there, and it was converted to 2Cl minus. So in a way, this reaction is showing you exactly the same thing, that they are putting chlorine gas in there, all right, and it is being converted to Cl minus. So the only way that that can be is if Cl2, okay, sorry about that if you can't see it, okay, it means that Cl2, right, gains electrons and now becomes what? It becomes Cl minus. So what it now requires us to do is now to use our knowledge. So we said E standard, E cell, is equals to E cathode minus E anode. That's our standard, isn't it? Okay? They told us what our E cell is, right? Remember there? They told us what our E cell is. They said it's 1.49. So now we know that E cell is 1.49. So which one is our cathode? Our cathode is the one that undergoes reduction, the gain of electrons. And we know, we said this is going to be what? That's 1,36. That's going to be our chlorine, isn't it? So in this case, that's 1,36 minus E anode. Okay, so now let's do that quickly. So we're going to say 1.49 minus 1.36, okay, and what does that give us? It gives us 0.13. So we've got 0.13 is equals to minus E anode, but remember we want E anode, so it means that our E anode value there will be minus 0.13 volts. Now all we simply do is go to our potential table. Okay, we are going to look there which one has a potential of minus 0.13. Okay, can you see it? There it is there. It's okay, going to try and show you. There's that value there, minus 0.13, and that value there is the value for plumbium. Okay, that is lead. Okay, that is lead. So it means that electrode X must therefore be Pb. Okay, all right, you can say equals to Pb. So we've identified it now. So it means if they didn't give you, there'll be some additional information that they give you that actually helps you to identify which one it is. Né? Alrighty, okay, let's go to the next question. Okay, they say write down the name or formula of the reducing agent. Okay, I didn't go through this one with you. Now please remember, we say that the one that is the anode, okay, undergoes what? Oxidation, isn't it? Okay, so which one is our anode in this case? We've just found out it's the plumbium, isn't it? So the one that is undergoing oxidation is the reducing agent. It kind of you kind of sorry about that. So you kind of flip them around. Okay, so the one that is the anode undergoes oxidation, but then it becomes what? The reducing agent. But the one that is the cathode undergoes reduction, and therefore it is what? It is the oxidizing agent. Okay, so in this case they said give the name of or the formula of the reducing agent. Okay, so it means that reducing agent, once we add that agent, Remember, reducing agent is the one that undergoes oxidation, okay, right? And remember, NOx, oxidation is what happens at the anode. Which one is our anode? It's going to be plumbium. So they said give the name or the formula. So we know that that will be, so the name is lead. You know, the funniest thing is that lead is actually written as lead. Okay, but it's actually spelled or rather pronounced lead. Okay, and that word there, I think it's from the Latin. Okay, plumbium, that's where plumbing comes from. Okay, but that's another story for another day. That's just a history lesson. All right, so they say the reading on the voltmeter becomes 0 after this cell operates. You remember that? You remember we said that? Okay, they say after the cell operates for several hours. Okay, they say give a reason for this reading by referring to the rates. You see, by referring to the rates of oxidation and reduction half reaction taking place in the cell. So what do we know about equilibrium? We know this is when the rate of the forward reaction is equal to the rate of the reverse reaction, right? So ultimately, the rate of oxidation, okay, equals the rate at which reduction takes place, and that is why the cell ultimately becomes 0. Simple as that. Okay, right. There's that question again. It's almost like they copied off each other, eh? But it's no surprise because it's probably the same set of examiners. Right, so in this case, the last questions, okay, they say a silver nitrate solution, okay, is now added to the chlorine half cell and a precipitate forms. You remember they said that that precipitate is silver chloride, right? Okay, so now they are adding, so in a way, what would be the net cell reaction here? It would be Pb, okay, plus Cl2, okay, which would become 2Cl minus plus Pb2 plus. Of course, this is not balanced, right? Obviously, you would need to, in fact, it is balanced. Yeah, I think it is balanced. Right, so this is what you'd get. Now, so now they are asking us, we're going to do exactly the same thing. When we add silver nitrate, what happens? The silver goes and steals away those chloride ions. Do you remember that, ne? So it goes and steals away those chloride ions, and now silver chloride is formed, and we know that it is not soluble, right? So when we add silver nitrate, it takes away those silver ions, and therefore what happens? It will now decrease the concentration of our chloride ions, and obviously, according to Le Chatelier's principle, we should now start favoring the forward reaction. Okay, now look at the question. They say, how will the reading on the voltmeter be affected? We said that reading should now, every time we favor the forward reaction, we're going to increase that EMF reading. Okay, so it will increase. Okay, right, and then now they say use Le Chatelier's principle to explain the answer to question 8.5.2. Okay, and how do we explain that Le Chatelier's principle? Okay, so we're saying an addition of silver, okay, if we increase silver ions, all right, so what's going to happen? It's going to now decrease the Cl minus ions, isn't it? So once we decrease those silver ions, what happens? The forward reaction is favored. Sorry that I'm just going to answer that quickly. So we decrease in chloride ions favors the forward reaction. Okay, so forward reaction is favored, or you can say shifts equilibrium to the right. Okay, shifts equilibrium to the right. Okay, and therefore it means that our E cell will increase. Okay, shifts equilibrium to the right. By the way, why does it shift equilibrium to the right? To increase or to replace those silver or those chloride ions. Okay, so shifts equilibrium to the right to try and replace those silver ions, and therefore in this case it will increase our silver ions. I'm just too lazy to write all of that down, but I hope that it does make sense. All right, ladies and gents, I know you didn't see my face for this one, for this question, but I hope that as you go and write tomorrow, so this is the almost last video that I'll be doing prior to you going to write, but I hope as you go and write tomorrow that you have the best of luck. Okay, I hope this will assist, okay, with the you know, those last few minutes preparations. Please don't let the nerves get the better of you. All right, please answer those questions as best as you can, and please don't waste time on things that you know, you are struggling with. Rather start with things that will build your confidence, and make sure that you work your way towards the other more difficult concepts. Okay, all the best, and thank you so much, and thank you for all those lovely reviews. Okay, I think you do best to try and recommend you know, the channel to other people. Just make sure that you try and also you know, subscribe if you haven't subscribed already, and I'll keep posting some more and more videos in the future. All right, thank you and good luck. Thank you. Bye.